hypothesis testing of the population mean of a continuous variable using the normal distribution. In this example, a machine is filling jars of honey with a mean of 460.3 grams, but there is no mention that the weights are normally distributed. But because we have a large sample size, we can use the central limit theorem, which states that for an unknown population distribution, i.e. something that's not normally distributed in this context, the sample mean will be normally distributed as long as we have a large sample. About 30 or more constitutes a large sample. So we have the population mean here. This value will go into H0 and H1. And then we have our random sample. So this is all about the random sample. All these values here concern the random sample. So the sample size, the sample mean, and the sample standard deviation. So the population standard deviation is unknown, but we can estimate it using the sample standard deviation. So we're going to calculate an unbiased estimator for the population variance. So using the formula here to work out an unbiased estimate of the population variance, and substituting the values of n and the sample standard deviation in, like this, we get the value 10.41. So we can use this value as an unbiased estimate for the population variance. Now we're investigating at the 1% level of significance whether the mean quantity has increased, so a one-tailed test. So for the population we have the mean and our estimate of the variance, and then from the sample of size 60 we have the distribution of the sample mean. That's the population mean there, and that's sigma squared over n, and our test value 461.2. From here, this value came from a random sample of 60 jars, and it's the sample mean. So H0, the null hypothesis, 460.3, and for H1 we're looking for an increase, and using a 1% level of significance, we have 1% here, 99% here, so looking up 0.99 from the tables gives a Z value of 2.326. This is the standardizing formula. This value is the population mean, and we're dividing by the standard deviation. Here's the variance, so we're dividing by the square root of the variance. Rearranging this will give our critical value here as 461.3. The test value is 461.2. So on the number line here, 461.2 is in between these two values, so our conclusion is to accept H0. So we have our acceptance region on this side, and we have our rejection region on this side. So our conclusion, accept H0, there is no significant evidence that the mean quantity of honey has changed. Accepting H0 leads to type 2 errors.